Alright, this is the code implementation section for the Prim's algorithm. Sheldon provided me this code. I applied it to our test data. So we have our input data down here. These points, which is represented in graph format here. This is the way the code will accept it, which is the distance between each point and with its relation to the other points. So for this case, S and itself, the distance would be 0, S and A, the distance is 12.8, S and B, 19.2, etc., for each point. Let's run the code. So here's our code, our output. As you can see, I've got a bunch of numbers instead of letters. I've written in the description what these numbers represent. So 0 is S here, 1 is A, 2 is B, so on and so forth. This will give us a set of edges that will connect this graph in the way that it should be properly represented as the minimum spanning tree. And that concludes the code implementation of the MST algorithm.
This is Prim's algorithm with a sample set of XY coordinates. Prim's algorithm is a minimum spanning tree algorithm whose goal is to find the smallest tree that is composed of all the vertices in a graph. This section then connects so that the implementation, the cryptography algorithm may take place. The minimum spanning tree will build a path that connects all the destinations along certain edges that are weighted, trying to prevent any backtracking in achieving the smallest total sum of the edge weights. We must navigate through the minimum spanning forest of the possibilities to connect the destinations. Given a weighted graph is this one right here. First we must choose a vertex from above graph. Let's choose B. Next step, now we must choose and add the shortest edge from vertex B. There are two edges from vertex B that are B to C with weight 10 and edge B to D with weight 4. Among the edges, the edge BD has the minimum weight, so it is added to the minimum spanning tree. Now on to step 3. Now again, choose the edge with the minimum weight among all the other edges. In this case, the edge is DE and CD are such edges. Add them to the minimum spanning tree and explore the adjacent of C, i.e. E and A. So select the edge DE and add it to the minimum spanning tree. Now on to step 4. Now select the edge CD and add it to the minimum spanning tree. Now on to step 5. Now choose the edge CA. Here we cannot select the edge CE as it would create a cycle to the graph, so choose the edge CA and add it to the minimum spanning tree. So the graph produced in step 5 is the minimum spanning tree of the given graph.
Talk about the way these feeders work. These feeders, and it's really important to our project. This little tube right here, this taking the compressed air. As it take the compressed air, is move this back and forth, and it gives individual components. This gear right here is holding the tape that goes along. As the tape goes back, it feels more confident. The rear is also fed on the tapes. So we'll take a look at the feeders tape. You can hear the compressed air go in each of the feeders, the clicking sounds. That's the compressor. Go to the nozzles right here, and the clicking sound. The nozzles pick up the components each every time. Take a picture to remember where to put it back. This is a closed video showing how the feeders pick up the components. Let's watch. This is how the tape is being changed on the pick and place machine. So the plastic is exposed its individual components, in order for the plastic to be released, it needs to be tensioned by this gear. So if you don't have enough plastic, you need to peel back more. So company lose a lot of parts from doing this. So you need to be careful when you're doing this.
I'm going to peel back the plastic. Now that the plastic is free, I'm going to wind it here, wind it here. Push down so I get as much tension as possible, and that's it.
What is that you just did?
I put tension on the plastic so that every time it feeds, the plastic pulls back and exposes the. I'm going to peel back the plastic. Now that the plastic is free, I'm going to wind it here, wind it here. Push down so I get as much tension as possible, and that's it.
What is that you just did?
I put tension on the plastic so that every time it feeds, the plastic pulls back and exposes the.
Alright, so the tape is ready now. So we'll put it back to the machines. And
that was a mistake. But if we just constantly put a QR code in the corner of that, box on the bottom, we could just shoot with a gun, and it links straight to whatever documents needed, like if we're logging stuff for the board, as it goes.
Okay.
And
So now it's going
instead of having to go, like, link the share file, looking for 15 folders, trying to find the one that
Alright,
folds
cool.
itself into the logs.
So unfortunately, I have to discard this.
alright, so this is how it is being done. This is how the feeders pick up the components. You see the flash, green flash, take pictures of each component.